The sixth learning objective in section 4.2 is to construct and interpret a confidence interval for a population mean. A consumer research group decides to test the life of a new line of LCD televisions. The group randomly selects 50 televisions to test. The data from this sample shows that the mean life of televisions is 57,000 hours with a standard deviation of 1,200 hours. Construct a 90% confidence interval for the mean life of a television. Round values to the nearest thousandths if needed. We're going to compute this confidence interval using GeoGebra. I've opened up the probability calculator in the GeoGebra window and selected the Statistics tab. We're going to compute a t-estimate of a mean. Our confidence level is 90%, so I'll enter in 0.9. The mean that they gave us from the sample is 57,000, and the standard deviation is 1,200, using a sample of 50 televisions. When you calculate this, it gives the output right here. Here's the lower limit of the confidence interval, 56,715.4799, and the upper limit is 57,284.5201. Rounded to the thousandths place, which is the third decimal place, we get 56,715.480 and 57,284.520. The next example says, risk of infection is a major concern for patients on kidney dialysis. A random sample of 38 patients had a mean of 112 days with a standard deviation of 144 days between insertion of the catheter and infection. Construct and interpret a 95% confidence interval for the mean length of time until infection for all dialysis patients. So we're still going to use the t-estimate of a mean option in GeoGebra. This time we're being asked for a 95% confidence interval, so I'll enter in 0.95. The mean of our sample here is 112 days with a standard deviation of 144 days and a sample size of 38 patients. Here's our confidence interval below, which goes from 64.668, rounded to 3 decimal places, up to 159.332, again to 3 decimal places. The way that we interpret a confidence interval is by talking about how confident we are that the interval captures the parameter that we're interested in. So in this case, we say something like this. We are 95% confident that the interval 64.668 to 159.332 captures the mean length of time until infection for all kidney dialysis patients.